So since there were questions last time about networking and stuff like this, I was thinking that it would be nice if we would try today to implement an own reliable streaming protocol over UDP. That is something that's rather uncommon, so I guess it will be interesting. And having done that by hand will, I think, demonstrate quite nicely how this operates in practice. So let's start. We'll create a new project. Let's stick to the, well, let's create a console application since we don't expect to need anything from Qt. Yes. Bildschirmfreigabe Nummer 4. Okay, now screen sharing is on. Sorry about that, but in the recording it will be everything. So the recording runs independently from the screen sharing. Okay, so I would call it user mode TCP because we simulate it in user mode. So let's start with that name. And then I guess we should first reopen our previous sample just to quickly take a look on how TCP works. So we have TCP server and we have the TCP client. As soon as it finishes opening, so the client goes to the left, the server goes to the right. We should have this. Okay, yeah, so here we have the same thing just implemented using, so without Qt. With the server, I don't remember whether we implemented this also without Qt. No, we did not. So let's quickly also implement the server here without using anything from Qt. So we'll need the same includes this we have here, so winsock2. We don't need this, we don't need that. We will be also needing to start Windows sockets and create a socket. Okay, so we have started, we have created a socket, and now we will need to listen on the socket. Although first we should maybe tell it on which port we want to listen. So first let's do bind s, comma, name. That will need again such a structure. Sock add in as, although we'll need two of them, so let's call it well, okay, we will only need listening, so let's keep it as this punct. Sin families equals af init. So it's more or less similar to here. Actually, we could have copied that. We'll want to listen on port 1, 2, 3, 4, and we should specify an address. So sin add punkt s sin add sun s add is equals and let's listen on localhost. Okay. So now we can bind. Yeah, bind reference size of we can do size of SR. Yeah, we need to cast this like we did here. Okay, right here. Now we can listen to our socket, comma backlog specifies. So when we start listening, it will start receiving connections, and we'll be putting them on in the internal queue, and later with the accept call we can get those connections. So here we can specify how many connections at most it should keep in this backend queue before we have accepted the connections. Just go with max, so so max con. Okay. And once we're done with the listening, later on we will close at some point, but for now we don't care. We now here need to make a loop where we will accept the connections. It takes as a parameter our socket. It returns a new socket, so the incoming connection is converted into a socket object. So let's call it new sockets, socket 2 accepted socket, I don't know, something. Let's just go with as in, like socket incoming. And here what we also get is we will get the address for the from where the connection came that we are now accepting. So we can create here another object, or we could also, I guess, pass null if we don't care. And since we use TCP, I would say we don't care. So we just pass null and null. The data could later be obtained by querying the socket as such as well. So this is fine to discard it here. Okay, and if it worked, so let's first check if it works. So if socket is equals invalid socket, then something went wrong. We could, for example, at this stage just abort everything. So close socket S and break. And at the end of our function, we should clean up, but we don't care for that for now. And if it worked fine, then we have now a socket with which we can do something. Normally you would now start a thread and give it the socket for processing. So let's do that. Create thread. Thread attributes null, comma null, null, comma start address. Let's quickly see again the how this is supposed to look. Since so dwort win API let's call it socket prods or server prods. Server prods, nice, sounds nice. Helper void param. Okay, return null for now. Create thread. So normally when you write code, you should probably call things more descriptive, but it's kind of very common when you write C code and need a lot of helper variables that you sometimes just don't call them in a particularly useful way. So that is not good, but it's acceptable. Okay, we have one. No, we don't. It should just be casted to the void. Okay. Yeah. Now we can close the handle. Okay, so the server part is done, and in principle the server will just run forever until some error occurs. We could add some break condition, but we don't care for it. What we should do probably is to add a cleanup at the end. I mean, we will never break the loop normally, but just to have demonstrated the proper way of doing things. So yes, with a cleanup. That is pretty much the thing that closes whatever was initialized with VSA startup. So after you make a VSA cleanup, you are not supposed to use sockets anymore in this process, and we need a return null. Main is one of the very few functions which requires a return parameter, but normally the compilation will not fail if you forget to do it. Okay, but so this runs, and here now we can what was it? Send let's v. No, let's v, not let's v. Socket, and now let's create a device buffer. So char of 1000. Size of both flux null, and this will return us the number of bytes written or an error or a negative value on error. So I think it's just a normal int. We are missing s. We need to get s. So int len. We need to redefine our socket. Just s is equals param. So okay, we received the text and we said we want to send it back. So send s comma both comma l. Although we should check whether that actually worked. So if this is greater null, then send and flux 0. We don't care. So send would return us the amounts of bytes sent. So if we would send more than what fits in the buffer of the socket, then it would just send a portion of the buffer, and then we would need to call send in a loop. But since we here just send a very short string, we are sure that this will work in one go. Okay, and here we will close the socket. So close socket s. We can also here we forgot to close the socket here. We will shut down it from this side. Normally close socket will issue a shutdown anyway, so in principle we could comment this out if we want. I'll just remove it for now completely. Okay, so we have this, we have that. I think redsv is blocking, but let's quickly check the documentation. Blocking means whether it is waiting for data to be there, or whether it will return 0 if I think it's not blocking by default. We will need to enable it. Or we just run it in a loop until we get something that is not 0. Or was that not blocking that needs to be enabled? I don't remember. Control. Okay, so blocking is the default, so this should work just fine. And only if you would want a non-blocking behavior, we would need to set a flag on Windows. You know, if there is like a lot of different platforms you use, then sometimes it's not. Sometimes you forget which behavior which platform expresses. So it's always good to check the documentation, even if you think that you remember everything correctly. So let's wait, and we of course want to do something with the string. Let's print it out. So that we send s, so that we see that it worked. So let's add text received, and we of course need to add the terminating null character just to be on the safe side. And our other code here, it just sends and it does not receive. Okay, so this will be fine. We need to include something to be able to print f as stdio. Now we can print f. So let's start our server. That's on localhost, that should be working. No, what's wrong? Okay, this thing does not. We are missing a library, which we already had to include last time here. The Qt libraries, they are compiled as DLL, so if they include a lib, this is not available to other programs that use Qt. So Qt has the same include, but it has it internally and it's not exposed in any way. Now it should build just fine. Okay, let's run it. So our server is serving, and now let's run our client. Yep, that worked. So now on this side we also can add some code to receive connections. To receive the data that is sent back. So we assume that send works fine. And we need to include SDIO as well. Okay, so where were we? Let's put the server here, the client here. The nice thing about Visual Studio, the newer versions, is that it opens you this window, which is then reused for subsequent calls of the program. So we can now restart it in this window. And oh wait, we have a bug. Len, we already have defined len somewhere. So let's redo it. And here we got received from, and then we got here the received text back. So as you see, everything works just fine. And now what we will do, since we have this code, we can start creating our own TCP based implementation of sockets. So let's get rid of everything we don't need. Oops, no. For optimal testing, we should either have two, again, a server and a client process, or we could just use two threads in the same program, and I think we will go with that. So this sounds like a reasonably easy approach. So let's create two files here, one for the server, new item, test server and test client. Sounds good enough as a naming scheme. New item. Oops. Client CPP, we will include a few things in both. So let's just copy some code. Okay. This and that, and then we will also need to make some threads. So here, server pods, right you, and client pods. And then we can copy our thread creation code here. We will need to add some. I enable that. No, this feature of Windows 10 is really nice, where you can have multiple things in your clipboard. You can copy one, then copy the other. You can paste the one, then with Windows V, you can then paste the other stuff from your clipboard. Let's include Windows #h, since we will need this. One thread where we don't really need any arguments for now, so let's just go with void, with null. Server prods and client prods, and let's start. Well, okay, that is already defined. Let's start a couple clients. Well, for now let's start one client, but later we will be able to start more clients that will then send data to the server and terminate. Okay. Nice. So at this point, of course, it doesn't do much. What we could do is we can, of course, quickly okay, we need the startup code first, so this we also need here. Oh, and one important thing, of course, we don't want the thread to terminate prematurely, so we will change a thing right now. So here, this one will be a thread, and here we will call it a server. Actually, we could maybe give those better names than just T. So let's be pedagogical about that, and probably will use a loop that's more elegant anyways. And this we will not want to close with the one return too much. We will here make a wait for single object for and we give it the server. So this will here log until the server thread terminates, which it probably will never, since we don't yet added any abort condition, but we could add one. So we could make it, for example, to terminate after having received a certain count of connections or something like that. So now for just reasons of quick demonstration, we can just copy this code here and quickly first check whether everything works with a normal TCP socket. One thing that is here, we will need to have a different server prod, since that name is already taken. So let's call it socket pods. Okay, socket pods, and then we copy from the client here our client side of the experiment until here. Suck. Okay, that do we need anything else? No, we have a text, we have the path, where's the here. Yep, that should work. Let's try it out. Okay, it throws something complaints. Let's see. Okay, there is some setting that is apparently if we create a Qt project, the default preprocessor definitions will already include this, but since this is just a console project, we will add that. It will also complain later about the linking error, since we have not included our VS2 lib. So quickly let's fix that. The nice thing about how the compiler works is that if you forgot some includes, it will just rerun the linker stage and it will not recompile everything. So this is quite nice. Okay, and we got what we wanted to. We should add some line breaks to it. So here and here we are on the server side. So server receive. For the other one we'll make wait, I forgot the N. For the other one we'll make client receive, so that we see. Wait, was it capital or not? Not. So that we will get nice. And here actually we could maybe really go for a couple of those. Int e is equals 0, e is less than 3, e plus plus. So we will make 3 clients. Each of them will send something. So this should work just fine. Yep. And what we also could do, but that's for later. We could read out the when we are inside here the address, and then write from which socket the communication originated. So on Windows, if you are addressing something, then it will create a new socket on a different port for every outgoing connection. We actually can watch this. Here is everyone. Okay, what do we need? We need this. And we should enable that and fast refresh. So if we run it, okay, then we should be able. Where is the process? here. So we have here our listening socket, and then we see the outgoing connections. So the outgoing ones all have different ports, while the incoming ones all have the same port as was seen, on which the connection was received. In principle, we could use bind to specify an outgoing port, but it's better to let Windows do it, since we don't want to reuse a port that would already be in use by another application. So at this level, the operating system has only the port and the IP to identify to which process, to which connection a particular package belongs. So if we would have two processes on this using the same port and IP, then the operating system wouldn't know what to do, or rather it would just not allow us to bind to a socket which is already in use. So we would fail at the bind stage, but just that you know why it would not allow you to do that. Okay, so we can close those two test projects since we don't need them anymore. Okay, and let's start with our own structure. So one thing to decide first is what sort of API we want to offer. So whether we want the whole thing to be a purely custom sort of implementation, or if we want it to be as much as possible a drop-in replacement for existing socket infrastructure. So one approach would be to be fully object-oriented, that we make an object called UM socket, CUM socket, and then have all the functions defined on it. Or the other approach would be to have some internal structures that represent the object and have individual C functions that do the different things. I think for starters, we'll just really start with our own nice object, and if we want later a simple C API, then we can implement this as a wrapper anyway. So that is the best way to go. So let's now create a new class. We will call the class C user mode TCP. We don't want the C on the file name. We don't need any base class. So this is good as it is. Let's pin those in place. Those as well. Wait, oh, we have a problem. We already used this file name. That is not good. We just rename this to main. And add a new file. The CPP file. User mode TCP. Okay. Actually, we could also do a different thing. We can add own directories. One thing to keep in mind with Visual Studio is that when you create directories, here it does not create those in the file system. So they are purely virtual. You can of course go to your file system and then there create directories and move the files around. So if you look, was it C benutzer source repos umtcp, then umtcp again, then you see here that all those files, even if they are here in directories, are here just on the root. But I find it usually useful to create at least some virtual directories for things that should stay together. So we call this umtcp. Okay, it's also nicer when you switch from between the files more often to have them together than to have them separated in a header and source virtual directory. That, in my opinion, is not very user friendly, especially if you have projects with more than a few files. Okay, so here we will include and stdlib, and now we will want to have some public functions. We need definitely a constructor, a destructor. Let's not do it virtual for now. User mode TCP. Oh, it's not pinned, damn it. If you want to move those around, they need to be at the same level of being pinned or not. Oh wait, and we forgot to add the tilde to our destructor. That's of course not good, but the compiler will complain. Now when starting out with C and getting a lot of compiler errors, it might sound like it might appear as if that is kind of annoying, but in fact it's quite nice, because this way you really find the bugs as soon as you produce them, and not just by the program misbehaving further down the line. Okay, so we have our constructors. Then we will need some listen function. We will want to have a port on which we listen. That should be an unsigned short. Or what's the default on Windows? Port here. Yeah, unsigned short. Where are we here? Port. Let's go with this naming convention. We will here at this level just do everything. So we will not give here an option to bind to a particular IP address yet. We could add this later if we want. So we have our listen. Then we will need to have for the other side our connect. So that will require a IP address and a port. Let's go with providing it for now as string, and converting it internally to some representation. We could also go with just providing here a oolong, but this would only work for IPv4. So since we don't want to be locked into using IPv4, we will just use a char and then internally convert that into an IP, even though initially probably we will stay just IPv4 compatible. We will, doing it this way later, be able to easily update the thing to be IPv6 compatible. Okay, so we have our listen, we have our connect. We will need some shutdown function to terminate the socket. And of course, in between, we will need something to send and receive data. Although this, now the question is whether we want our own implementation to be blocking or not. Because if we make it blocking at this level, then we will need to have some worker thread which will run independently. So I would say for now we will just go with a non-blocking approach. Receive void then and was heißt der? Stern ulen. Wait, we don't need ulen, it will just return us here directly, so we only need to pass it the buffer. Yep. And for send, well, no, we need a buffer max size, so int max move and send. We'll have here buffer. Okay, send is read only, so we can make const, and here buflen, since we need to say how much of the buffer was sent. And for starters, that probably are all the functions we will need. Later we can of course add something to change additional parameters. Wait, is that true? Oh, I forgot one. We need an accept function, of course. So the accept function will just return us a new socket, and it does not really need any further parameters for now. Yeah, okay, so we have listen, we have accept, we have our connect, we have send, we have receive. We have shut down. That should be enough. That must be enough. And as said, for changing parameters, we'll add functions later on. For starters, we'll just start with default parameters. So let's quickly implement all of them. Or rather, add empty prototypes for begin, and then we can with empty prototypes, empty bodies, and then we can look where we go from here. I'm still thinking whether we should maybe rename shutdown to close. Let's do that, because shutdown is more a... It's like it sends the signals to terminate the communication, but it does not close the socket on the operating system level. And normally, I'm not sure whether you have shutdown on Linux, so let's go with close here, since it shuts down the communication anyways. Why don't we have ushot? Because we should probably include Windows here. ushot is, I think, one of the Windows defines, although we just can include winsock too, since that seemed to include Windows H internally anyways. Okay, so we have this, we have that. Okay, what we could now do is we can rewrite here our samples to well, let's do it like this. If f0, so you can quickly switch between those, although we will probably won't need switching since they won't be compatible, so you cannot like create a self-made TCP implementation that would be on the Windows level that could talk to a operating system implementation on the same machine. So we will probably never switch between. So what we are now creating is an own protocol which will be using UDP, and which will, on the application layer of things, simulate the behavior of TCP, but it will not be binary compatible with TCP, such that we cannot use it to talk to a client which does not know our protocol. Okay, so for the client it's easy. We need to include our of course custom class header here and there. Okay, so C user mode desktop new client. I forgot the asterisk. Connect to name. So let's go with localhost again, port 1234. We need to define it as const. Otherwise we cannot. Otherwise we cannot pass locally defined strings to it. Okay, then we can do send. We can have some things at least defined globally, although maybe we should rename them to send buff and receive buff. That was unused here, and that's found buff. That is used here and here and here and there. Send buff is already initialized. We could make it bigger. We don't need to, but why not? Length. Okay, we will go. Let's send len. Where did we use that here? And for the receive, let's create an own variable receive len. Okay, which we use here. Okay, and here we will make receive len is equal. We need a loop, because I said this will be a non-blocking implementation. Receive len is equals. We can add the blocking implementation later on. Receive. What was it? Let's both size of receive buff. Okay. Okay, and if this is 0, so if this is less than 0, then it's break, something went wrong. If it's 0, it's fine, we just did not receive anything. And if it's greater than 0, so the last case that remains, then we can we will just send the same string back. So send here can be non-blocking, we don't care. We will just use, wait, we forgot something. First we wanted to send a send buffer before we start receiving. So send send both, send the len, send buff, we have here, I forgot the D. Oops, that will be a typo, so here. Okay, send buff, send len. And we don't care whether send is blocking or not at this point, because we don't care for the result. And then here we send back the thing which we have in the buffer, send comma, and we send back the same length. And again, we don't care whether it's blocking or not, and we don't care for the result. And we wanted to print it first, so print f. Actually, I could just steal this line here. Yes, and we, oh wait, buff, and this we will need, and this we will need as well. So let's steal this line. So it's pretty much analogous to what we did here, just that with objects it's a bit less typing, since we don't need to add one more parameter, and we can close it without more. And once it's closed, you can also delete it. That is not the best practice, because if we delete it, so when we close the socket, we should wait for the. So when we close it, we tell the other side that it's closed, and we should wait for a package coming back that acknowledges that it was closed. So we probably should not close it, and we probably should. I mean, we can create new sockets like this, and we can implement close such that it will be deleted internally afterwards. This one strategy, or we could have an explicit function like you know it from Qt, a delete later. I somehow like this idea, so let's go with that. Okay, but we won't call it delete later. We will call it dispose. Since yeah. Okay, and to prevent people from trying to delete a socket object, we will make the destructor private. We wanted to add the dispose here. Okay, we will need to implement that. At least for now, give it an empty implementation such that it compiles. Okay, actually, it won't compile since we are missing all the return values. So if we try to compile it, it will complain. So let's quickly add it. Return null. Oops. False. -1 to indicate an error. -1 to indicate an error. False. Well, close should never return. Should close return false? It could return false. I mean, if the connection is already closed and we try to close it again, then we will say that it was an error, and dispose, of course, just disposes of it. It doesn't need to do anything. So at this level, we already see that we probably will need some helper thread for this, at least for this dispose function to work correctly. And yeah, and no, and for now that's that. Okay, we have this, we have that. We might change this later to we might even directly implement this as blocking. We will see. For now, let's go with this. And for this implementation, I would go with just using what's available in the STL library. So we might at some point want to use Windows events so that we can release a lock, but I think at least the simple cases should be covered by the STL, so that should work fine. Okay, we have this, we have that. Now let's implement our server side. So test server. And we will need to implement this as well. Hash if null. So let's quickly copy some code from here to there. Did that much. Wait, that will run forever. That is not quite what we want. Well, it will receive, and if it runs it received, we want it to close, so we make a break here. Once we received one valid answer, we kill our client connection. Oh wait, I need I need a dispose as well. Okay, that's it. So here we will cast our p-void onto our client object. Equals param zack. Oops. Okay, and we need some of the buffers, so those two. Could implement them here. Okay, so this goes away. This does not have a definition, so zack, 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 zack. Wait, I think I might have forgotten that here. No, I did not. I forgot one thing here. I mean, as said, we probably will never use this code again, so it doesn't matter, but and I forgot that here as well. But we want to keep it functional just in case. Okay, we have this, and but here we will receive forever, and receive will fail. Okay, one more thing. Of course, if this would be blocking, then it would not be good practice to make this lock up forever. So if we have this case, we should add a wait or sleep. 100 microseconds sounds reasonable, so that we are not wasting too much CPU time here. If we make it blocking, then this will not be a problem anyways. But since I'm not sure that I will have it blocking or not in the first implementation, since we are just making it up as we go along, let's stay on the safe side. And for the server, we need that anyways. Okay, we do this server. Wait, so say server. That's fine. Okay. Yeah, and the server will just run until there is a issue. So like until the client closes. So if the client closes the connection, and receive here will return a negative value, and we will break, and then we will close our end of the connection and dispose of the socket. Just add a few line breaks to make it look nice. Okay, yeah, then we need also the implementation of the server side. So this will be quite analogous. So you need to create the socket. Just copy this for now. Okay, one line break here. Okay, so connect. Well, not connect, listen. Oops, listen. On port 1, 2, 3, 4. We don't have any send. Here we will be accepting connections, so accept. Okay, and now the accepting can either return something or nothing. So if this is null, it means that there was nothing to accept. So we continue. And we also add a sleep. just in case, since for now it probably will be non-blocking. And if it was successful, then we can copy this part of the code. We pass this as argument. Socket ports is fine. Let's say we're giving those things better names. Okay, so the thing is created here. If it's not have been created, then we just sleep and wait for the next round. Yes, and we need a break condition. Yes? This one? Because this one uses Windows implementation of the TCP protocol, and what we want is we want to implement our own. So, I mean, I could just delete it. We probably won't need it anymore. But I thought for now I will just leave it there. Yeah, some parts are compatible. Like here, the creation of the thread is the same, just that. Oops, I have a typo. Yes. Just as I was starting to say, we need some sort of abort condition for here. So the accept could also say that something went wrong, and now we are not able to accept any more connections. So it would be nice to have here some sort of indication. Like here we didn't care. Here we just are in the endless loop, and well, we could create so the invalid socket value is pretty much just a well, everything. Well, actually, those two should evaluate to the same thing. Like if you invert 0, it's the same thing as -1. But that is a strategy which you can use. You can take a known invalid value. So, for example, null is defined as invalid. So, in theory, on Windows you could, or rather, let's say differently. In theory, in some operating system that you write yourself, you could make it such that you can have valid memory at address null. But on Windows, it is designed such that the memory allocator will never give you a memory block that starts at null. So it can be defined as invalid. And what you also can do is you can define another value as invalid, namely the maximum value a memory pointer can have, because this would mean that I mean, in theory, you could maybe store like one. Could you? No, you couldn't. It is also invalid because like the pointers started at 0, and if you would use the highest value, then you would not have any room above it to address anything inside your structure. So we'll do the same thing as they did here in the head. Where was the header here? We will use -1 since this evaluates to all f's in hexadecimal notation, and define for our own use a invalid socket, but we will call it different. So hash tag define user mode socket, and then we just cast. Okay, wait. Okay, we need the type to be, well, we don't need it. So since this is evaluated whenever it's inserted, we don't need to first have the definition. -1. So now we can check against this, and if we see that where are we here? No, yes, wait, server thread there. So if this thing, if per socket is equals to our invalid value, then we break because something went wrong and it's considered an. Why did it complain? It should like that. Okay, it says yes. Okay, now it's fine. Okay, so we have the case where nothing happens, where we just repeat. We have the case where a fatal error occurred, where we just terminate and close and dispose. Actually, we should here close the socket as well as just for good measure. Okay, so now we have our code, and now let's start continue work on our own implementation. So first thing we will need is we will need to have some own socket object which will represent later a UDP socket. So we can quickly here open our UDP socket example, since I think we wait, did we do that with Qt or with C? I do not remember. Okay, we did that with Qt, so that doesn't help us, so we need to do it by hand. So first of all, wait for this to close. One more thing we can do is we can move I don't like this include to be here. Let's just assume that everything's that in I have no idea. So if you want to have like private includes which you cannot, which will not contaminate your header. So if you don't want to include here anything that might be problematic with other includes, what you can do is we can create an internal structure which will represent our private variables as a socket, and this structure can access everything that we include here, but it will not contaminate our. So when whatever includes that will not have a problem. So let's say struct. We'll call it M, like for member, and then inside here in our constructor we just create new M, and then in the destructor we dispose of it. Okay, in this way we can define here things which are just which requires includes, which we don't want to have in the header here. Although we have ushot, which also is only defined in window H, but that is a smaller issue. We could do this if and def. So if ushot is not defined, define ushot if voila. So now we are sure that even if we include this header from a C or C++ file which does not know what a ushot is, that we will have it at our disposal, and since it's the same as unsigned shot, it should be fine with any other definition. Or we could just use ushot directly here, but let's stick with that. It demonstrates one more nice function. Okay, so and as I said here, did I make this private? I made it private. Nice. Wait, one more problem. So while M can be private, we will somehow need to be able to call this. So let's do it protected. And from our helper thread, we will be able to access this and maybe those internal variables, because maybe we want them to be accessible. If we see that we don't need them, we can always add a private here, then it won't be accessible at all. Okie dokie, so here we wanted to have a socket. We can now have two strategies. Either we add a constructor to this thing, or we just initialize everything in this constructor. So maybe let's go with that. For starters, it's just null. For starters, it's just null. I mean, if you want to bind it, then we would need to make it. So maybe we should. Okay, we will create later a second constructor, which will be used by the accept function, but for now we don't. So this will already assume that we will want to have a socket of some sort. So we create a new socket. So we can copy some code from what we already had here, just that we need to change a few things. So if init stays the same because we still use the internet protocol, but instead of stream we use datagram. So we can actually take a look which socket types Windows would offer us by default. Raw socket is something that is in theory still available, but nowadays you need at least administrative privileges to create a raw socket. So for most applications it is not really useful. And the idea was that you can create a socket that will be able to receive data bypassing the operating system's TCP and UDP stack. So there would be use cases where you might want to do that, but most of the use cases where it was used is rather to just implement some exploit or spy on some data. So nowadays Windows does not allow to use those types of sockets unless you are the administrator of the system. So for our application we will just stick to the normal datagram sockets. Okay, then in the destructor we will why is it complaining? Ah yes, socket is already pointer, we don't need that. And in the destructor here we will close the socket. Yeah. And we will definitely add here much more stuff as we go along, but for now it's good. We only need this, and when we start listening, then we will basically want to open to connect our UDP sockets. So that was bind s to that we can copy as well from our server here. Zack. Okay, port. Okay, sock adder, so we will need to do some casting here. Asterisk and reference and socket address. Wait, it's of course not S, it's M socket now. And this should, what does this return? Integer. Let's quickly check the documentation whether I guess it returns 0 on success and negative value on failure, as most of those functions do. But it's always good to check do not. So if no occurs, bind returns 0, otherwise it returns socket error. And socket error is probably defined as -1 or something like that. Yeah. So if bind is ungleich, or if bind is equals 0, then return true. Else return false. And later we might want to have some more error information, but not now. So at this point we are ready to be able to accept connections, but now we will need some sort of worker thread that will actually receive the UDP packages and do something with them. So here we will also need to add some more code and a helper thread. Yeah, so let's just now thinking whether we should use like a global object that is shared by all of them, or whether we should implement it on a per socket, per thread basis. I think for now we should just go with an own thread for every receiving server, and then later we can look into improving that into sharing a thread. Yep, let's go with that for now. Handle edge server. Where is that the best option? I mean, in theory we don't necessarily need to wait on it on just once we terminate. We don't need to keep a reference to it here, so let's just do it without a reference for now. And if we later need one, we will add one. So we need to create another process. So some listener prods. Okay, and we pass to it this. Okay. Right, yo, and one more thing we will need to do is we will need to add a internal function that will be doing that. So let's say don't care for the return value. We will call it also listener. It does not need any arguments. We need to define so that this can access it actually. So okay, we have not said what Win API is, so we will need yeah. Okay, so here we can now call Stempel okay, and on this now we can run the listener despite it being private. And we need to add somebody to the listener, so for now let's put it here. And this needs a return value. Don't care for the return value, so let's do with return null. And when I think about it, we definitely need some sort of server structure to handle those things. So let's create here a struct SUMTCP. Let's call it as user mode listener. Now for starters, let's put everything that we have here, and then later we can look what we can elegantly outsource to different structures. So we have here our listener that will have a loop. For now, an endless one. We'll later think about some termination condition. Well, then we would have a listener basically for every individual. Yeah, let's maybe just call it socket. Let's call it user mode TCP prods, and because we might need this for other things later as well. TCP prods, and here we will rename this to to what we rename that. We will think about that later. That we need to think about this now. Let's call it socket process for now. So what it will do, it will receive packages from UDP and process them, and it will also be responsible for doing all the different. Why is it complaining? Ah yes, because we changed the name, so this needs to be here. Yeah. Okay, so we run this on that knows what it is. Oh, I pasted it not where it should be. Now it's fine. Okay, so and now we'll here receive. What was it? It's from our socket oops, comma, now the data, so we need some buffer. Let's go with something. Let's add a definition here. how big we want this to be, and let's go with something that's definitely too big. Later we can change that to a more reasonable value. Len flux 0. And we need we need a buffer for this because it might be a bigger thing. Yeah, let's go with this name. That will definitely be bigger than it needs to be, but we will look later into the right size. And the length, it will return how long that was. What was the original name of that? Formlen. Okay, so int formlen reference on this, and we need to cast this to what was it? Sock other asterisk. Okay, and if this is greater 0, then we have something to do. Else, and if it's less than 0, then we break because there was an error, and we will need to set some error. So set error, comma, etc. For later. And if we could, yeah, let's go with that. If it's greater equal 0, then we do something. Why is it complaining? Yes. With the preprocessor definitions, you don't use semicolons, and since in C everywhere else you use it, so it's easy to have a reflex that to always type them. Yes, and here we said we listen on localhost, so here we added to do. But for now, I think if we set this to 0, it will just listen on all of them. But for now, we just want a localhost only implementation, or yeah, let's stay with that. Okay, so we have this, we have this. So now we have to think about our package format. So when we will be sending and receiving packages, they will have a, let's say, a very basic design. So we'll need to think about where to put what. So we will be able to set everything up. So for one thing, what we need will be an opcode, which will tell us what does this package do. So let's call it. And let's say that we want this to be 1 byte long, and what the rest will do, we will think about later. But for now, we have the opcode. So what we of course also could do is we could define a header structure as user mode. So we have our let's call it byte is defined as unsigned char, so we don't need to type so much. Byte u opcode, comma, then we will have 3 empty ones, and for now this is everything, assuming a 32-bit alignment. We will of course add more things later on, and what we can do is we can add char something like this. So it's like a array, but it does not has any length. So basically what this does is it will be pointing at the next memory after this. at least it should maybe be more explicit here. Let's say 3, so that we are sure where our data will end up. So basically, when we access payload, then we are accessing memory which is after the header, which is quite a nice nice shortcut. So we have here our data, so we can cast them per packet. Where's our receive buffer? Here it is, s equals then we would like to have a package length, a payload length. So let's go with int. In principle, nowadays you should use size t for everything that is size related, but the old API always uses int. Let's stay with it. Payload len will be from len minus size of header. Oops. So this way we have package payload and payload len for further processing, and now we need to define a couple opcodes. So opcode syn or sync, how do you want to call that? Do we have a preference? Not really. Let's call it syn for synchronization 1. Then we will need a acknowledgement package. Let's call it 2. So we will do it slightly differently than how a TCP works, since the normal TCP would use multiple flags and in the same. So they would use not like individual opcodes which have different functions, but they would have different flags which you can set on a package. You can save, of course, traffic this way, but it is not as elegant. So here we will have an explicit acknowledgement package for everything. Okay, so we have syn, we have this. Then once we want later to close the so first of all we need for synchronization. Later we will have for payload data. So let's call it data. Maybe 3, 4. Then we will want to have something to finish the connection. So when we want to make close, that will be 5 and 6. And if we want to somehow just reset everything, we'll just go with reset. And reset does not have. So reset is like you can set reset if you want to kill an existing connection without wanting to have a acknowledgement for anything, or if you would receive data and you don't have a connection to which the data belongs because for some reason, for example, you have rebooted your server, but your client was still running and it thinks that there still is a connection. So in such scenarios, we don't send fin or anything. We just send the reset package back to notify the other side that it should terminate whatever it's doing outright. Okay, what we will put into those we will think about later. So now let's create a over here. So switch per first per package, the packet opcode. Okay, so we have seen. Okay, we will then need to add a break for each of those. And the default case. Yeah. To do error. we could maybe in this case also just automatically reply with a reset and kill the connection, but that's something to think about later. Okay, so we have our incoming package parser. We have some rudimentary beginnings of our package format. So what do we do next? We could try establishing a connection. So if we receive a sync package, then let's make a function for that. How do we call that? Maybe first we just write the code and then we see how long it is, whether we want it to, where we want this to go. So we receive a sync package normally. Well, we receive it in both cases, whether we are the server or the client, since we want the communication to be bidirectional and to have a three-way handshake. So maybe first we should actually write down our protocol. So we have, okay, let's copy this a few times. So we have our client, then we have our server. Okay, and when we establish a connection, the client sends a sync package to the server. Yep. The server then will reply on it with a sync package with a sync egg package, and then our client will need to still send an acknowledgement package out. Will we use? So for this we will also use the sync arg, which we defined earlier. Opcode. Okay, and then at this position we have established a connection. So we can start sending data, and our normal data communication will be a data package, which we send to the server, to the server side. Doesn't matter which one it is, and this one of course has then to answer with a data acknowledgement, and then we can continue. So in principle at this level, at some point then the server will send us some data, and we will reply with a data ACK and so on. Wait, that is one. That doesn't look great, but okay. And and at some point we will want to close the connection, so we'll send a finish, then we will get a fin egg, and then we'll reply with our own fin egg. And of course alternatively we could decide that something went wrong. Let's say it's a server, and the server will just reply with a reset. It would be nice to find for data some different something that's also 3 letters. So payload maybe, or wurscht. Let's leave it 4 letters. Okay, so this is our communication scheme. Okay, Okay, now take a look to our, well, we will need of course a few help variables. Here, something that tracks, keeps track of our state of the socket. So let's create an enum. OMTCP state. And we'll have none. So that socket is in no state, and we have it can be listening. Listening, that's an internal state. Then we'll have connect, so syn send. What else? What other states do we need? Then of course syn received, syn arc received. Is quite a few states that we need. Let's think. Yeah, so we have basically we need. So we have syn send. We have syn. Well, when we receive an ACK, then it will be connected. Let's call this connecting. And let's write here. Send connected will be syn arc received. Okay, and at this point we can communicate, and when we want to terminate the connection, then we have disconnecting, comma, fin send, and disconnected, fin received. Received. Okay. We don't need more states. Okay, so UDP state. The socket will be initialized to state none. Okay. M state. Oops. Now we have our protocol. Okay, we don't need this for now. Okay, so we have received a syn package. So here we know we are a listening socket, or at least we expect to be listening. So if M state is not listening, then something's wait. Okay, let's add a underscore here and there for better readability. Right, and then we need to add it here as well. Okay, so if we are not a listening socket, then something's really bad. So we just break, and we want to reply with a reset. So we create a new package. We set the opcode to our, what was it here, reset, and then we send send to it was our socket. Buffer is this thingy. Size of, haha, we forgot one more thing. But we'll do it, add it shortly. Okay, flex 0 to we can use from, and that is pretty much the same thing, just that without a reference. What we forgot is we should check here once we have, well, no, here before we do that, if where's the receive length is greater or equals size of header, because if it's not, then we have a problem. to do error continue. We continue listening for other connections. We could of course here also try to reply with an error with a reset, but we assume that if like it's not a valid package from our protocol. Oh, that's a good point. I forgot something very important. We should somehow indicate in the header, in the header, yes, in the header of our package that it belongs to our protocol, because I mean, if we receive some random TCP random UDP packages, then we don't want to try passing them if we can at the very beginning somehow reasonably say that it's definitely not our own code. So one thing that can be done is that we add some value. So either we add it before the opcode in the first double word, or we just use a 32-bit indicator. I mean that there is not really a strong preference to any option. It just the question is just what is more likely that we will accidentally pass something that's not intended for us. If we use a 16-bit 16-bit marker, then of course the chance is 1 in 65,000, and if we use a 32-bit, then it's 1 in 4 billion, which is pretty much equivalent to impossible. So let's go maybe with that. So we will have here a protocol ID, which will be large enough. So let's define this as long like this. That reads nice. Protocol ID. And of course, whenever we create a package, we first need to add this, but we don't do that now. So okay, here with our reset. Okay, and we will of course need to define ourselves some protocol ID first. So let's go here, TCP ID. What we can do is we can write it as a 4-letter string within character single quotes, and this will then give us the numerical representation. So we could call it use this as TCP. Yeah, let's call it like this, user mode TCP. So this is our protocol ID, which mostly guarantees that we will not pass any chunk packets. And now, so yeah, here one thing we need to assign this, and the second, first we check of course whether the header is the right size, and then we check this is if it's smaller than that, then it's an error, or if well, we can do this because we have the buffer anyways, and as long as we don't access the data, everything is fine anyways. From len is wrong, there should be retsvlen here. That was already a copy and paste bug. And here of course this check also ensures that this will always yield a positive number or 0. 0 is also fine. And now, since we know here that the package is large enough, we will be checking whether protocol pro ID, oops, I wanted to call it prot ID, not pro ID. So if this is not equals our TCP ID, then it's also an error, and as with the wrong size, it's a silent error, so we will not reply back with anything. We just drop the package. We can of course log internally that we received a malformed package or a package that is not for our protocol or stuff like that, but that's like for making everything prettier later on. Okay, so this is fine. Now we know this thing works. We can answer here with the reset signal if we see that we want to reset the connection if we were not in listening state. Yes. So if we were, however, in the listening state, then at this position we already need to create a socket. a new instance of socket, which we will later be able to receive to accept with our accept. So path socket is equals new, and here as we will give it the socket which we already have. Do we want to do that? Team. We have to do that for it to be able to send things out. Yeah, okay, let's stay with this. So, but of course this means that we would need to have a socket type defined here, which we said we don't want. Can we do it somehow more elegant? Yes, we can. We can use ourselves as an instance. Socket listener. Let's go with this name. So we'll give this thing just us as a argument, and since we are already for 1.5 hours at it and there is no end in sight, I think that will be a project for more than one lecture. So I will need to think about some homework, but I think this we will do later once we have at least some very rudimentary basic infrastructure. So sock is socket, because it will be the same. It takes a copy, which will also mean that if we close the listener, all open connections will break. On Windows this would not be the case, but usually you would not close your listener anyways early, so it's fine to stay at this. And of course the connection state here is connecting, since we know that that was already received. Okay, so we are here in our prod, so we created the thing. The state is set to connecting. We are happy with that. And now what we will need is we will need somehow to keep track of all that, because we will receive the subsequent packages for this socket within our listening socket. So here we will come in with the data packages. So to make this work properly, we should have a map that will keep all our a track of all our connections, and we should track the port and the IP address. So the thing gets complicated. We will need another helper structure. What is our here is our socket. So first of all, here we will. So first, let's create a helper structure that will represent a. I mean, what we could of course do is we could use this socket address structure that is used by the socket API. But the thing is that I think it does not by default contain a length. It just contains a maximal size. And there are two different types. So we do have this socket in socket in normal, and then I think it was called 6. Yeah, for IPv6. So what we could do here is create a structure SUNR user mode address. We will give it a doing it that. Well, we could assume that we know the length, since all those different types always start with this family field, which tells us whether it's IPv6 or IPv4. So in principle, we don't need that so strictly. Let's try without it. So let's do. We need to include some std things. Hash include map. So std map, and this will have here as one element. Now we will need a known structure. There is no way around it. because this thing yeah, it's also just a placeholder. Because we wanted to force it to always allocate the biggest amount of bytes that we might need. So we will create this and we'll use but we could directly call this a union. But let's yeah, wurscht. Union SA SA4. So 4 denotes IPv4 and SA6 will be the IPv6 version. Why is it complaining? Do we need a different include for that? Perhaps vs2 ipdef. Okay, that is. Oh, that was vs. Okay. It's still complaining. Why? vs2. Oh, now it's not complaining. It just needed time to think. Okay, so now we have a union. So the memory block is as big as all those three. Like are as big as the biggest of those three elements, and we can access them individually. Of course, at any given point in time, only one of them is valid, but we know that all of them are defined such that the first short, the sin family, is well, is always tells us whether it's an IPv6 or IPv4, and this one, as you see here, also has just like some placeholder data, although 14 bytes. That's not enough for IPv6, so that will most likely be just big enough for the other case. Let's quickly check that. Constant x is how big is this? Yeah, it's 28, so it's definitely too small. So we need this one to be here as well. And then we can say that we want this as a key, and as a value we will want to have the whole socket, a pointer to the socket. And we should go with just using normal pointers. We'll not try using smart pointers here, so let's call this here a socket map, or maybe sock map like this. And when we try to use it, this should start complaining that it is missing an operator for the less than operator for this. So we will try to provoke the error quickly here by adding. Okay, we need to. Okay, so sock map insert. Sorry, m sock map add. Can we wait? We should do a more. We have this already defined here, so we can use this for our for. Because this will always guarantee us that we have enough size, and we can now use for as the key. And this is equals our pointer. Now when we try, that should set it's complain that it's missing the. Okay, it's already. It marks it here as red, but we don't see where the problem is. When we try to compile. Sorry, it's complaining here as well. Okay, if this fails here, then it probably will. Oops, that was wrong. We just need a reference to this. Then we'll not start creating the template, so we need to try it again. This function compile. Okay, we still have a syntax. Okay, here it apparently wants to have something. So let's just add an empty break. Now we have the complaint from the part of the compiler to create the template, implement the template for our map, that we have that the binary comparison that this thing it does not exist. So we need to create our own. So here what we do is well, this returns an integer. Does it? No, it returns a boolean operator. Const reference operator left. Wait, const reference left and right. We'll just say return first to see whether it will compile without complaining, and then we will implement the content. Yep. So now if L socket address family is not equals R punct sa family, then of course return false, because they cannot be the same. And now if they are the same family, then we can compare them directly depending on their size. So we make a size value. Len is equals null, and now switch sr.family case af init, then len is equals size of socadrin. Oops, break. And if it's init af6, so IPv6, then it will be this size. And if it's none of them, then len, well, what do we do then? Then basically we will I mean, we could just say default case, and we then just compare the entire memory block, since this is the biggest thing anyways. So it's okay. Let's write it like this, and because this then covers all the cases, and now we can return compare compare buffer1 is L dot, well, actually it's just reference on L, reference on R, comma len, and this I think it has to be less 0. I mean, if we would use more than 0, it wouldn't matter. We just want to check whether they are not the same, and to order them in one particular direction. So whether we mess up the direction here will have 0 effect on our code later on, so it's fine. If we would care for it, we would check the documentation of mem compare to see when it returns -1 and when it returns 1 when comparing those. But anyhow, so now we have here our operator. So now this should be working. So now we need to use the map. How do we do that smartly? So sync packages we have to handle at this level. Everything else, so let's cut this for now. Everything else needs oops, the one is up here as well. Everything else needs a socket, so default, any other package. Oops, let's go with this syntax, and we will need to add a function here, void process packet as how did we call that? SUM header, okay. SUM The nice thing is, if we say that it's a struct, we don't need this struct to actually be defined before using the function. You can copy this as well. So this comes here, or maybe further down. Let's put it here. Now we can paste what we copied, and here we can have this switch again. It was small m, wasn't it? Probably. Yep. Okay, and now we will try to find some auto e is equals socket map. Find from, and if this if equals is ungleich end, is not equals end, then wait, e dot second process package package more, and else well, just so we know that it is a package that well of a sort that we care for, but apparently we don't have a connection for it, so we will reply. Actually, we could put this into an own function. Yes. Send reset. Stock adder Stern SA. And we need, well, it's always reset. We don't send yet a reset reason, so we don't need anything else. So this is fine. It might be a good idea later to sort those functions a bit. Zack. Okay, tag for we need the length as well. Comma int len. I prefer to be this way. And of course here we don't need this cast. Actually, we can copy this before we change it, because we will be needing this cast in the when we use our send reset function. Zack. Wait, why is it complaining? Type def struct. Sock add the as you see, I'm trying to avoid dependencies on any includes in our own header, so that is a bit it was not as it was from. Okay, and here default, well, break, we need break here as well. So you know, with switch, if you are in a case, then if you don't break, you just fall through to the next case and the next case and the next case. Why is it still complaining? I will debug that later. Wait, just let's finish this. We don't need a reset here. So we don't need a break here, since this will break. But let's see what's wrong with that. So again, that should have an asterisk. That should want an asterisk, because so wait. So this thing takes sock address asterisk. Yes. So we want to cut. Well, we could cast this directly to that. But if you look on the definition, you look on the definition of our socket address, yeah, type def this and struct that should be the same thing. So do I have a typo? Well, one problem after the other. So doing this solves the issue, and here it's complaining. I mean, you could also just go the void asterisk route and screw it. Void asterisk accepts any pointer, so we don't need to cast it here to anything. And here we just cast this on socket address, which we void here that we know we need. So that much to this. Okay, and now it's quite elegant because we have a function that always can be used to reset a connection. We just need to tell it what to reset. From len we have here, that's fine as well. This, I mean, we could, for more symmetry in everything, write it like this. That looks nicer. Okay. Yes. So the whole rest of the communication, of the processing of the communication, happens in here. When we reset, see if this, when we see this, we can ignore it. Yeah. Send reset we have. Okay, so now the connect function is still missing. So this will be the user side. So here, at this point, we have a socket object created, but we have not did much with it. Let's copy some code from here. Okay, so a few improvements we can already start adding. So first of all, for our socket here, we should make every socket aware of what it is. So let's call it our address. Let's go with the full name. So every socket will have an built-in address structure. So then we can update our our listen. So this we don't need. We go just for address SR. Yeah. But we don't have port at this level. And here we need to go for SR4.port. But this at this point is just IPv6. So let's add this will be something for later. So here we will be sticking to the IPv4 initialization. Here we can that will also not work as nicely. Let's make a helper function. Let's put it here. Get user mode address size. That takes a pointer to this. Our reference pointer is better. Maybe stay with this naming convention, and we can basically copy this to here. Like this, and then return the length. So here we'll just go with the length of L. Since we know that they have the same family already, then it's safe to go just with taking with what is this complaining? that needs to be const, since we don't edit it anyways. Okay, so we have our address size, we always have that, so this should be fine. So here we can now add get remote address of this. What we also could reference, what we also could have done is we could have also just created add a function here, even though it's a union. That should work. Yeah, why not? I mean, if we are using objects, let's so with structures you can do it easily, and I think the union should accept that as well. We just don't need an object, we just go here with this. Yeah, it's not complaining. I mean, we should maybe put it further down. So now we could actually just go with L dot. No, it doesn't work. Okay. Okay, that's a pity. With structures we could do that, but apparently with unions we cannot define a function on a union. This somehow sounds too long, but well, let's stick with it. So we have this here and we have this there. So we already have this update, and then we can take this code. Where were we? Yeah, connect here. Just that here we have more or less this thing pasted in, so we can just go with memcopy. Haha, we forgot one parameter. So if we are going with the normal API, then we will need to give a length here as well. So we will test client. So the way here we had the star. Wait, we said we want to use the IP. Okay, then let's not call this name, then let's call this address. Yeah, address. Okay, so if we say that we actually want to go with address, then we will still need to do something to get to add support for IPv6. Oops, this that should be 6. IPv6. Yeah. And we don't need this, so we have the we set everything here. Well, that should be then actually like this, since it will be before that. Okay, so we create, we bind, and then we need to send our connect package. So we can copy this, just that here we will want to have our sync package, and then we will want to send to send to m socket, comma buffer is our package, so that we can copy from here. Yes, and we will need to use wait, not we don't want to break things. There is a small problem. If we create a connection, we will create a new socket, but we'll create the socket locally, so we will not bind it to anything. Those data, we don't need to do any of these things, or at least definitely not the bind. We can leave it here so that we can know to what we connected, but we will need to use this. We don't want to bind to it, that would be a mistake. We want to send it to that. So address, and here that means a reference, and here we need to get user mode address size from reference address. That's correct. Yeah. So we have initialized the remote address we should add a comment because this is a very easy mistake to do. So okay, yeah. Past. Wait, was it? Why is that complaining? That should not be complaining. We just added a comment. No, it's not complaining. Yeah, the intelligence is slightly slow on this. So listen, connect was here. So we initialize it, then we send out the package, which is just a sync package. We will probably add additional things later on, and we will return true. Since we don't expect anything bad happening here. Okay, one thing we will need is we will need to create a thread for us to be able to receive things. So likewise with this, when we did listen, we will need to create a thread. It can be the same, I think. Okay, then almost so state, yeah, because we get in here, we check whether it's a valid package. Not quite that easy, because if we are not a listening socket, then we don't want to redirect anything. So actually we should do it well, so here we don't want to find anything, we want just to process it ourselves. So how do we do that in an elegant way? We could just look for our own state. That's probably the best way. So if state is listening, then we pass this thing forward to be processed by whichever other thread, and else we have to process it ourselves. So this goes here. Where did we put the function process package? Okay, let's move this further up again. Let's put it here. Process package, package. Yep. I mean, we could make it even more elegant. We can give this function a Boolean return value. So if this is success, then we break here. If this is success, then we break. And if we return false on parse package, then we would send a reset signal. That's more that looks better. Okie dokie. And for now we'll just always return true, but we can change it later. Okay, so we get our package for processing. When we send things, we create an own thread, which is not bound to anything. So our own thread for this socket will just listen, well, send and receive data on a random port. We might later want to change this such that we will be using one defined port always on the client and on the server side. But for now, since we want to emulate the TCP behavior, we just stick with that. We forgot to set the state. We need to set the state to connecting. Why is that not working? Where we have our states connecting. Okay. Right here. So now we look at our process, so we can here. Yeah. So this one, if it. Okay. Wait. Let's think. So if we get the package, async package, then we set the state as connecting, and we will need to reply with a sync acknowledgement package. And on the other case, we expect also a sync egg package. So syn x. So here we will need to send. So let's go to our send sync. That was this. Okay, let's remove the unneeded line. Connecting. So we received it, we created the socket, and we will now here answer with the sync acknowledgement package. Right, using what was it? Syn underscore egg. Okay, so at this point both connections are in a connecting state. This automatically sent a syn egg. That is not yet correct, right? That is still, I think, not correct. So we send a socket acknowledgement, and the other end, on which the other end is waiting, but we ourselves are not waiting or anything. So actually our state should already be connected. So here that will be connected, not connecting. And then the other end, so we set it to connected because we already got our sync egg, and then this one. Yeah, we don't want to have like a 4-way handshake. We want to save on traffic. We are happy with a 3-way handshake. So this sync egg. No. Wait, let me see our plan. So where did we plan this? Here. We send sync. Then we are connecting. This one sends sync X back. Okay, then it's still on connecting. And we then send a sync egg as well, and then only then both are set to connect. Okay, so no, so this stays on connecting. So we got a sync, we send out a sync ACK. So in both cases we will now receive here a sync ACK package, because if we are the one that requested, so now we got the sync ACK from here, and we are in the connecting state, but now we need to, after we received it, we will need to send our own sync egg in reply. Yes, so if we receive, and we started with connecting state as well. Wait, I want to avoid sending one too many sync egg. That needs to some proper thinking. Okay, so we are in the we received the sync acknowledgement, and then we can check our state. If our state is equals connecting. That is not going to. We might need an additional helper state. Because if we receive a thing acknowledgement package and we are in the connecting state, then we should reply with a thing egg package. So let's first of all create another helper function, send thing egg, so that we don't have too many individual functions that, I mean, we can just copy the body of that thing. X and some X, and we can use this here to send this in egg. Okay, so we start the connection, we send just a sync package. We receive the sync package. At this point the remote site is in the state of connecting. Now we received it, we will send our own sync and egg package to the other side and set ourselves to connecting since we are waiting. And the other side, when it receives the sync egg and is in connecting, should reply with a we had this somewhere already used, I think here. That will be just send the sync package. Okay, so send sync egg. We always do this on our own address, so m address, so reference address, and well, actually we could put the len function there, so we could improve that. Since we are sending, we don't know. Let's stick with the method we used until now. Size of the star. Egg, and we set our current state to connected. Okie dokie. So let's do a short experiment. So we send sync, and how do we know to write it down? So we send the sync package. We are in the state of connecting. The other end received it. It set itself also to connecting, and it sent a sync egg. So now we received it. We are in connecting. We set ourselves to connected and send a sync egg, and then we have on the other side the problem that it will also want to reply once more. We do not want that. How do we do that? Then I mean, we could add an additional state. Probably is the easiest thing to do. If we have another state, then we can know whether we were the one to initiate the connection or whether we are the client, the server side. Yeah, I think we will. Do we have a better idea? I don't know. I don't think so. So let's go with, for now, adding a different state, and then we can. So connecting. Well, we just will call it connecting 1 and connecting 2. So connecting send. Yeah. connecting 1 and connecting 2. Sync send. Connecting 2 means sync and synac send. Connected, synac received. Okay, so we are here in the listener, so here we received and we are already in 2 because we know that here we have already replied, while here we are, okay, this is for later, while here we are connecting 1 because we have not received anything. Then we can go back to here. So if this is thing 1, then we have to reply. Is that correct? I think so. Yeah. And if we are in thing 2, then we don't. So, and in any case, we can set this to connected because we have received the synac package. So now the connection is established. Yeah, and we should maybe add some breakpoints everywhere else. For now, okay, I would change one more thing. Here, I would not pass SA since we can. So in this case, well, we could do that always. Let's remove that from all of the calls. I think that is doable. Since we have our nice getSize function, that should. Then we don't want to cast it to sock adder. We just want to stay at from. And then we don't need from len. Here we don't need this either. We won't have. Oops. Here we will just go to. Well, we should do that a bit more elegant since we have this struct here somewhere. Well, it's a union. Here. We should be able to just use this here just the same. Zack. Okay, so we don't need a cast in this case since then. But actually we need it. Okay. And here make a get omtcp size. I should call it leng. That would sound nicer. Since the all other nomenclatures are always to call it n. This already is a pointer, so this is fine, and this we can now copy here, and that is already much nicer. Nice. Okay, so at this point we will have the established connection. We could run it and test it whether it works. But in all cases we will end up here. Well, for our both clients, let's try that. But one more thing. Was it main? Here, for now, let's just go with one client. Should be working, yeah. Well, including up, something is not right. So 5 minutes today to debug it. So we go here into our receive procedure. And we see that we don't receive anything. We can put a breakpoint here. Okay, we already get a -1 because it's is it non-blocking? Let's see what's the errors. Might be that it is. But it should be blocking by default. I don't think that's normal that this is. So it's it's a large error. Who SA would block? Which one is this? Well, it's 2733. And what did we got? 271E. Okay. So it's not a problem with the blocking thing. Great. What did we say? 271E, was it? Oops, that didn't copy again. Damn it. 10013. 10014. Okay. It does not like our address, so let's see what did we screwed up here. From address, from len. We could add some additional space just to be on the safe side. It is definitely more than we might ever need, so let's see. Okay, so in this actual case we would want to have to get the what with a get last error. Let's see if it fails, how it fails, or if it works fine. No, it's still the same error. Is the socket valid? The socket looks valid. Receive buffer is this thing. Size of the buffer is that thing. From len. Reference on the integer is also fine. So let's see whether our listening works fine. Yeah, probably because it does not complain. That was 0. So, oops. That's also a bug. But let's see if just the listen works out fine. No, the bind fails. Sorry. That must be unlike 0. I think that might be the problem. Okay, so now this works okay. We still end up here with the same error. Are we which thread are we? M. No, none. And if we are in none, then we are the receiver. So let's quickly put a breakpoint here just to see that this is definitely where we want to be. Okay, now that this one starts also its own thread. Wait, one more thing. Just to be sure. So the state is set here to connecting. But the other one is really set to none. Did we say this need to be set to connecting? We didn't. Okay, so this is another bug, but it's not a bug that explains our current problem. State EUM. Okay, EUM listening. So we forgot to set this, but it still does not solve the issue why we get here an error. Okay, bind and we receive from sender address for file length sender I think I know what the problem. I think they want to know how many bytes we are giving them. So this will be an in-out sort of variable. In-out optional, okay. That should be fine. Now it should work. Let's try it. Yep. That was the problem. We need to tell it how big it is, what we gave them. So now the results, of course, much smaller than what we set it to, since it's just the size of the actual sock adder in structure. So we can remove this here. We can put a breakpoint again here, just to demonstrate. So as you see, we give in a 1C, but we get out a 1-0, since it doesn't use the whole structure by default. And here we already received the package, 8 bytes in size. That sounds okay. Actually, I will just run it and see whether we end up once, twice, et voila! It's working. So maybe we should add some debug information to the whole thing. So here printf %pair socket, and here this. Oops. Oh, we are 3 minutes over time, and I'm sorry about that. So this will be the last thing we do, and then we are done for today. There will be no homework today, since there isn't much to do homework about yet. I think we need to get this to a working state before I can task you some homework that would not be too complicated. Any questions? Yes, I will do that right after the lecture. OBS Studio. OBS. Okay, any other questions? Okay, if there are no other questions, then that was it for today. See you next time. Yeah? Okay. Also fine? Sure. Ask away. Okay. Yes. Yes. No, because we are always picking out the right chunks. So you mean in the from hex function, or you mean generally? Well, generally, mdata contains as many chunks as we tell it to contain, and you can access the chunks by the index. So mdata from something will always give you the chunk at the index I. And this is also why somewhere else we have this I divided by here by chunk size times 2, since here we want to generate the right chunk index. So then we get how many bits one chunk has. Sorry, it returns how many bytes. Size returns the count in bytes, and we multiply this by 2. Wait, chunk data from I, size of chunk. Wait, and I is okay. Hex string here is the amount of nibbles, so the amount of 4-bit entities in the string, and this is why we multiply this by 2, because we multiply it here for the division. So we want to get the chunk based on the I value of the position value in the string. So we want to I mean, we could write it also differently. We could divide I by 2 so that we have the byte and then divide it by the count of bytes. I mean, I could write it down like int byte num is equals byte index bitte index. Called byte index is this, and then here we have our byte index divided by the amounts of bytes in one chunk. And then so we will for the first how many, for so now with the current chunk size of 16-bit, we will get for the first 4 characters 0 here as you can here write so for the first 4 the chunk index will be 0, for the next 4 the chunk index will be 1, and so on and so on and so on. Well, it's an array, but the value of m data will be the address of the first chunk, yes. So what you could do, could write this also like this. That is more or less the same thing, because the pointer arithmetic takes into account which type m data has. Oops, I didn't want to compile that, but now it's too late. So if we would define m data as void, then this would be equivalent to chunk index stern size of chunk, or it would also be equivalent to why is it complaining again? Choice risk my data that should be fine. Do I have one too many? I'm missing one. Actually, I can just remove this one. Huh? No, I didn't have. Shit, we need to cast the whole thing then back to chunk type. Where were we? Byte index 1 2 1 2. So this line is equivalent to this or that line. So here in this case we are really just working with individual byte index within our chunk and addressing it directly. No, first it will be 0, then it will be 1. Okay, you're welcome. Any more questions about anything? C++ programming, programming in general, meaning of life? Okay, if there are no questions, then we will stop for today, and we are 11 minutes over time. Sorry about that. I will maybe try to be faster the next time, and maybe we will quit a bit earlier. So, see you next time. Bye bye.